We're going to take a look now at aqueous solutions and solubility. A compound is soluble in a particular liquid if it dissolves. So dissolving and soluble mean the same thing. Now for our purposes, the liquid is always going to be water. And a compound is insoluble if it doesn't dissolve. So insoluble and not dissolving are the same. An aqueous solution is a homogeneous mixture, and a homogeneous mixture is another word for solution, of a substance with water. And there's going to be much more water than there is the dissolved chemical. Now, one thing that we're going to look at in this chapter is when ionic compounds dissolve in water, they actually dissociate into their component ions. And I've highlighted the word dissociate because it's a new vocab word, and we'll look in more detail as what this process entails. So let's look at an ionic compound in its solid state. This is a depiction of sodium chloride. The purple spheres represent the sodium ion, and the green spheres represent the chloride ion. Ionic compounds in the solid state are three-dimensional. Each cation is surrounded by anions, and each anion is surrounded by cations, and they are held together by the attraction between positive and negative, and the positives are as far apart from one another as possible because they repel, and the same thing with the negatives. So ionic structures are highly sensitive to distance between the ions, and ionic compounds are always solid at room temperature because these ions have to be a very specific distance from one another to be stable. Now let's look at what happens when sodium chloride dissolves in water. When it dissolves in water, the ions come apart, and each sodium is completely surrounded by water, and each chloride is completely surrounded by water, and they're dispersed evenly throughout the water. Now, I just want to point out that this picture here has these ions grossly oversized. The ions actually fit in between the water molecules, but we just wanted to show you kind of that they're evenly dispersed and they separate from one another when they are dissolved. That's what is known as dissociation. Now, substances such as sodium chloride that completely dissociate into ions are known as strong electrolytes. Here is a picture of a setup that is often used to identify strong electrolytes. And there's actually a video clip from YouTube that I have lower down in the block that you can look to see. It looks like a chemistry professor actually performing this type of experiment. And what it is a light bulb that is attached to a power source such as a battery, and it has two electrodes. When these two electrodes are immersed in a solution that has dissolved ions, like sodium chloride, the ions allow electricity to go between the two electrodes, and the light bulb lights up. So strong electrolytes are often identified by this setup, and any strong electrolyte is going to allow a light bulb to light up. Now let's look at what happens when polyatomics dissolve. Here's an example of an ionic compound that has a polyatomic silver nitrate. Now we know silver has a non-variable charge of +1, and nitrate has a charge of -1. When silver nitrate dissolves, the ions separate. They dissociate in water, and if we had that set up illustrated here, in this solution, the light bulb would definitely light up. What I want to point out is the nitrate stays together. A nitrate is one nitrogen, this blue sphere, with 3 oxygens, these 3 red spheres. So the nitrate is going to maintain its structural integrity. It's going to remain 1 nitrogen and 3 oxygens with an overall negative charge, and each silver is just going to be a monoatomic +1 cation. So these are going to separate, and as I said earlier, they would allow electricity to be conducted, and this would be a strong electrolyte. So when compounds containing polyatomic ions dissolve, the polyatomics dissolved as their intact units. Now, one of the things I want to show is how we actually would write out something dissolving. So let's look at sodium chloride. Here's sodium chloride, and here it is in the solid state. If we dissolve it in water, what's going to happen is the ions are going to separate out. Now, sometimes dissolved sodium chloride may be written like this. Let me just go over. Here's our formula for sodium chloride, and this AQ stands for aqueous, which means that it is dissolved. Now, when you see sodium chloride AQ, this is an ionic compound that is dissolved in water. Any ionic compound that is AQ is actually dissociated. So this is really how sodium chloride exists in water. Sometimes the shorthand notation is used to indicate ionic compound is dissolved, but we as chemists know that if an ionic compound is dissolved, then it's going to be separated into the constituent atoms that make it up. And this is how we would write the equation for for silver nitrate dissolving. The silver separates from the nitrate, and these AQ means that each ion is completely surrounded by water. This would be a solution which would contain mostly water and then some silver and nitrate in between the water molecules.